Assalamu alaikum and welcome to Basic Statistics 2 class. Today we are going to discuss the second type of estimation, which is interval estimation. So what is interval estimation? The process of estimation in which an estimate is expressed by a range of values within which the true value of population parameter is believed to lie is referred as interval estimation. In previous lecture we have discussed about the point estimation, in which we estimated the true value of population parameter by a single value, single sample value. But here in interval estimation, as it is cleared with the name, that interval means there should be range of values. So in interval estimation, we estimate the true population parameter value by a range of values in which we believe that this true population parameter will be lying in somewhere in this range of values. For interval estimation, we use a method called confidence interval. So let's see what is this confidence interval. A confidence interval estimate of unknown parameter theta is an interval computed from the random sample of n values. You are familiar with this, that we take some random variable from the population, and in statistical inference, where population is unknown to us, where population is not given to us, so we just use the sample values. So same is with the confidence interval, that we will measure some values from the sample values with the statement of how confident we are that the interval contains the unknown parameter. Now confidence, as its name is written here, confidence interval. So here we will find some interval of values with a confident statement, that how confident we are. For example, how which percent how much we are confident. For example, we say that we are 90% confident, or we are 95% confident. So this is called the statement of confidence. Now a confident interval estimate is in the form of L is less than theta is less than u. The endpoints of the endpoints that bound the confidence interval are called lower and upper confidence interval. So this L represents the lower value of that confidence interval, and U represents the upper value of that confidence interval, in which the um population parameters value is believed to lie in. Now it will be more clear to you confidence interval estimate for a population mean. Now first of all we'll discuss about the confidence interval or confidence interval estimate for the population parameter, and here it is written for large sample. What are large sample? A sample is considered large if it is more than or equal to 30. If its item or its size is more than or equal to 30, then it is believed to be a large sample. Now, here we have two conditions in which we are going to use these two different formulas. When population is normal, now this population normal means uh, the normal probability distribution, which we have discussed in our first topic, that is probability. So there we have discussed about in detail about the normal distribution. So this population is normal means that this population is from the normal distribution, and the population standard deviation is sigma, which is represented by sigma, is known. So whenever it is given in your question that population is normal, or population is taken from the normal distribution and its standard deviation sigma is known, so we are going to use this formula, where this first part will show the L value, that is lower value of the confidence interval, and this upper part will show the upper value of the confidence interval and less than or equal to mu. So we believe here that this mu value of population mean lies between these two values. And the second condition is when population is normal but sigma is unknown and n is greater than or equal to 30. Now sigma will be unknown but the population is normal. Also the n is greater than or equal to 30. Then we replace this sigma by s, which is sample standard deviation, and sigma is population standard deviation. So if population standard deviation is not given to you, then you will use sample standard deviation. So now we'll do some questions on this. This will be more clear to us. Now question number 15.20 part B. This you can get from your book from exercise number 15. Let the observed value of the mean, that is x bar, of a random sample of size n is equal to 20 from a normal distribution with mean mu and variance 80 be 81.2. Find a confidence interval for mu. So first of all, we need to know, or we need to realize the situation that which of the situation are we are going to use here, which of the formula we are going to use here. So first of all, there is the variance of the population is given, which is 80. So variance of the population is given. Variance is denoted by sigma square, and when we take under root of the sigma square we get sigma. So here the first condition is satisfied, that the population standard deviation or variance is given, and also the population is normal distribution. So we can use the first formula here. Now as the population is normal and the population variance sigma square is known, so we use the following formula for the confidence interval of mu. So this is the formula. I have discussed this formula with you before, and now we need to know the values. This is x bar. X bar is the sample mean. Sample mean was given to us, which is 81.2. Then standard deviation sigma square, and when we take under root we get sigma, and this is 8.94. And then n was given in the question, which is 20. And okay, when sigma is known, we there is no necessity of n being greater than or equal to 30. But if sigma is unknown, then the condition of greater than or equal to 30 applies. So here you will say that and because in previous we have discussed about large samples, but if sigma is given to you, then n should be less or more, either it could be less or more than 30 when sigma is known. Okay, then a confidence interval, we have to find 95% confidence interval. So here confidence statement of 95% is given to us. Now this confidence level is represented by 1 minus alpha percent. So when we remove the percentage, it becomes 1 minus alpha is equal to 0.95, and when you subtract this from 1, we get the value of alpha is equal to 0.05. Now why we are doing this all? Because here in the formula there is a tabulated value given here, which is equal to z alpha by 2. So to find this tabulated value, I am doing this process. So then alpha by 2, when we divide it by 2, it becomes 0.025. Okay, now for z alpha by 2 we substitute we subtract 0.025 from 0.5 and then see the table number 4 area for the standard normal distribution on page number 545. um, 0.5 minus 0.5 minus 0.025 is equal to 0.475. Now by finding this 0.4724750 within the table, we get this value in front of uh, 1.9 and below 0.06. Adding them we get 1.96. Okay, now from where we've got this value, we got this value from this area table, which is also given in your book. So here we can see that we have to find the value which is 0.475, 0.475 or 0.4750. Here when we get we find the value 0.4750. Okay, exactly this value we have got here, 0.4750. Now it is in front of 1.9 and it is below 0.06. So here the same I have done, that 1.9 and 0.06, I when we add that, this we get 1.96. So this is the value of z alpha by 2. This is the tabulated value. Now uh, we put the values in the formula and step by step we solve these values. Then finally we get two values, one is lower limit and the other one is upper limit. 77.28 is less than or equal to mu is less than or equal to 85.12. So we can also write it in this form, and this is the confidence interval for mu. Now the next question, for making a difference, this is the next question, which is 15.25 part B. A random sample of size n is equal to 50 from a normal population yielded the sample value x bar is equal to 190 and s square is equal to 800. Find a 95% confidence interval for mu. So here, as the population is normal but the population standard deviation is unknown, here we have n is equal to 50, which is greater than 30. So uh, this second condition applies here, and we are going to use this second formula for confidence interval of mean. Okay, so here we have written the second formula, and again, as we have done previous question, we will write the data which we have got here. Now we have got here s square, which is equal to 800, but in formula we need just s. So we will take under root again and we get 28.28. Then n is equal to 50. Then with the same method, confidence level and this confidence level, and again in same method and in same table we will see this value for z alpha by 2, and which is same for this because the confidence interval was same. Now when we put the values and finally in the formula, and step by step when we solve the question, then final value we get 182.16 is less than or equal to mu is less than or equal to 172.84, which means that the true value of population mean lies between these two values, which is the confidence interval for mu. Okay, now confidence interval estimate of a population mean for small samples. Now This formula is slightly different because this is for small samples. Small samples mean less than 30. When population is normally distributed and the population is normal, but sigma is unknown and also n is less than 30, we use t-test instead of z-test. So here we will use t-test. Before this we used z-test, but here when sigma will be unknown and n will be less than 30, so we will use t-test, which is and the tabulated value t is read as t alpha by 2 nu. This nu is the degrees of freedom, which is equal to n minus 1. When we'll solve the question, it will be more clear to you. And this s is here small s, not capital S. This is again the table for student t-test. This is different table. Okay. Now, question number 18.7 part B. A sample of size 16 from a normal population with unknown standard deviation gave x bar is equal to 14.5 and small s is equal to 5. Find the 90% confidence interval on the population mean. So now uh, when we solve the question, as the population is normal but sigma is unknown, here it is mentioned that population standard deviation is unknown, and also n is less than 30 because n is 16. So we will use the confidence interval, which is x bar minus t alpha by 2 nu into small s by under root n less than mu less than this. Sorry, this is positive sign plus sign here, which will be clear in the next steps. So this here is my mistake. uh, Once you have to put minus and then plus sign. Okay, here we have written all the data which was available to us, and again the same method for confidence level, which is 1 minus alpha, and here this is 90%, so 1 minus 0.90, it is equal to 0.10, and then we divide it, then we get 0.05, and nu is equal to n minus 1, which n is 16, so it will be 15. By looking at the table 18.1 students distribution, you can get it from your book also, and um, in this slide I have also given this to you, this. So here we'll see, this refers the nu and this refers the alpha. So nu was 15 here and alpha was 0.05, so we'll get this value 1.73 753 value, this value in front of 15 and below 0.05, 1.753. So here you can see that the tabulated value is 1.753. Now putting the value in the formula, when we put the value, look, here is positive sign. Please make correction here. This is plus sign here in the second statement. Okay, now when we put the values here, and step by step, when we solve this question, we get value 12.31, which is less than, mu is less than 16.69, and this is the confidence interval for mu. And this is all for today. Kindly solve the questions related to this topic so that this will be more clear to you. Thank you so much.